As students, I'm really happy to meet you here in this wonderful time. Today, I am going to talk about the project analysis. Okay, so what is a project analysis? As the name says, project analysis means analysis of project. Analysis of project. Analysis, we know. Okay, so analysis means do some research on the part and parcel of the activities we do. That's called analysis. What is a project then? A project, being a management students, you know what do you mean by a project? Am I correct? A project is nothing but a aimed work. Aimed work. I mean aimed work. It means the time limit would be there, the cost would be calculated, and everything would be done. That's called what we say a project. Am I correct? I can give you an example for that. Take, for example, building a house or building a complex or any programs. Take, for example, corona injection program. So these are called example for the project. Okay. So that project we are analyzing, but analysis we are doing on the project. Okay, but here in mathematics, in our case, what we do is that we are doing the project analysis for optimum cost and optimum time. Okay, optimum time, optimum cost. We say cost here, so optimum is minimum among minimum. The time, definitely nobody wants to go more time to finish a project. So optimum time, yeah, very minimum among minimum time. Optimum cost, that is the time very minimum among minimum. That is what our aim. We are using mathematics here. By using the treatment of mathematics, we try our level best to bring a project a successful one, so that it is optimum for us. You must understand that uh, in project analysis, the main thing is that the activities and events. Okay, activities, you must know that the activities are represented by like this arrow. Okay, like this or like this. Anyway, these, so activities are represented like that. Another one is about the event. Okay, we will do the problems at the time you will understand what is an event. So event, we are writing our node, we say, and that's what, like this we are doing that. Okay, like this or like this or like this. These are events or node, we say, and these are activities. So these activities have the initial point and the final point. Okay, and this is called the head of an activity. This is a tail of an activity. Okay, this is a tail of an activity. This is a head of an activity. So in the project diagram, what we do, this particular events are connected by activities. Okay, like this, we are connecting the two event by an activity. Okay, as I told you that this is called a tail of an activity, and this is called a head of an activity. Okay, so according to some um, logical connections, it is possible to make the total project time a minimum. Okay, the total project time a minimum, it is possible by mathematics, by drawing a picture consist of like these activities and like these nodes. Okay, so we are taking one problem now. Look at that. We have to draw a project diagram for the following sequence. Okay, now what are A, B, C, D, E? A, B, C, D, E are activities. That's what you have to understand. Are what? They are activities. They are what? activities. They are activities. Okay, it's not given fully, or activities. Okay, suppose A, B, C, D, E. How many activities are there? One, two, three, four, five, six activities are there. Okay, so six activities. Do you understand what are the activities means here? Take for example, we are constructing a house. Then it consists of lot of activities. Take for example, raising a wall, then connection, water connection, electrical connection, then all windows, doors, those are called activities. Okay, suppose there are A, B, C, D, E, F activities are there. Six activities are there, and logical sequence are given like this. Like this, logical sequence are given like this. Okay, A should be finished. That is, activity A should be finished before D, and B should be finished before C. D should be finished before E, and E should be start after C is over, and E should be start after F. Okay, these are the logical ideas given to us. According to that, we have to make a diagram, project diagram for that. That's what is our aim here. So this some way it is a logical sequence on the basis of the type of the activities and the availability of the materials, all those things. These logical ideas are given to us. This activity should be finished before D. That is, activity A should be finished. Then only D should start, like that. Okay. So how to draw the picture here? Okay. How to draw the picture here? That's what our aim. Now look at this particular picture. In this particular picture, the activities are represented by the arrow mark, and the events or the node are represented by like this round. Okay, right. Now look at that. A should be finished before D. Look at that. A is finished. After then only D starts. Second condition, B should be finished. Then only C can start. Look at the picture. B have to finish. Then only C can start. And E can start after D. So E can start after D. Right. Then E can start after C. E can start after C. At the end of the C only E can start. And C can start. E can start after C. That is, E can start after C. And F should be finished. Then only E can start. F should be finished. After that only E can start. Okay. So look at this particular picture. The first one is called the initial event. The last one is called final event. Okay. How to find the initial event? Look at this particular logical sequence. The logical sequence, before A, no activities are there. Am I correct? Before A, no activities are there. Similarly, before B, no activities are there. That is, there is no predecessor for A, as well as there is no predecessor for B, as well as there is no predecessor for F also. Okay, and thus A, B, and F becomes the initial event for this diagram. Okay, so that's a way we have to find out which is the initial event and which is the final event. To find the initial event, we have to see this predecessor. A don't have predecessor, B don't have predecessor, and also F don't have predecessor. Okay. Now look at that E, but E don't have successor. Am I correct? See, E has predecessor, E has predecessor, E has predecessor, but E has no successor in it. Am I correct? So that becomes the final node or final event of this particular project. Okay, so all others have the predecessor as well as the successor. For D, A is a predecessor. For C, B is a predecessor. For E, D, C, F are the predecessor. or we can say successor also. D is a successor of A, C is a successor of B, E is a successor of D, F, C. So on the basis of the predecessor, successor, it is possible to make a project a diagram. Okay. And that's the way we are doing this. Okay. So in the next class, we will be looking at the another diagram for the given problems like this. Okay. So this is what given to us, and we will be seeing this in the next class. Okay. Till then, I have to say thank you for you. Thank you.